Again, it's a rich thing.
What is going on, guys? Welcome back. In today's video, we're going to talk about unit testing in Python. So let us get right into it. Alright, so unit testing is one of those things that are not very popular. A lot of people dislike testing. They think it's useless, or at least they think it's not interesting. It is not the most fancy thing that you can do in programming, but it is very important and very practical. What unit testing basically is, and this is what the name already says, it is testing your units in your code, testing the individual units in your code. So you're not doing integration tests, you're not doing some workflow that you're testing the individual functions and classes and so on. So let's say I have a function x that does something, or a function, I don't know, multiply, and I want to know if that function works properly. Then I write some tests. And usually what we do if we don't do proper testing, I think most of you will know this. Let's start with a Python file called myfunctions.py. This is going to be a collection of functions that we're going to test. They're just going to serve as sample functions. What we usually do when we have, I don't know, my function here, and we have a parameter x, and this function should, I don't know, return x to the power of 2. Now, this is something that we don't really have to test because it's one statement. It's not even a proper function. I mean, it is a proper function, but it's not a complicated function. What we usually do when we have something like that and we want to make sure if it works properly is we just go with print statements. We say, okay, print my function of 10, and we want to know, okay, does this work? And then we do it for some edge cases, maybe for negative numbers, maybe for 0. Maybe we want to know what happens if I enter a string. So this is how we usually test the functions. If we don't do proper unit testing, we write a function and then we just do some print statements to see if the result is what we actually expected. Now, this has a lot of downsides, depending on the function, of course. If you have a script with 2 functions and it's just a simple script that does 1 or 2 things, you don't need to do unit testing. Unit testing is useful if you have a medium-sized or large-sized code base and you want to test the functionality of the individual functions. And the good thing about unit testing is that you have tests that can either pass the test or fail the test. And the good thing is that if you change the functions, let's say I have a complicated function with like 5 or 5 is not really complicated, but let's say I have like 20 statements in that function or 25 statements in a pretty complex logic. And then all of a sudden I see, okay, I can make this function simpler by removing these 3 lines and by adding 1 line and by doing this or that. But I'm not sure, does this function still work in the way that I expect it to work? And what I have to do then is I don't have to rewrite all the test cases. I can just press a button and run all the tests that I have written before that. So the good thing about unit testing is that you take the time to write a couple of good tests one time, and then you just have to rerun them every time you change something in your code. And in this video, we're just going to use some sample functions here. So we're going to start by importing math. Import math. We're not going to need it right away. So for the first function, we're not going to need math. But the first function is just going to be a sample function that is doing some basic multiplication. So multiply with loop. Let's say this is the function, multiply with loop, and what we want to have is we want to have a parameter x and a parameter y, and what we're going to do is we're just going to say return the sum of y for placeholder in range x. So this is basically just what we're doing here is we're just running a loop x times x iterations, and every time we add y to the final sum. So this is what we're actually doing here. This is also what multiplication basically is. What are we doing? We're adding y x times. So y times x. This is not really complicated. Now, how do I know that this function works? Now, again, I want to mention here, those 1-liners or 5-liners are not really complicated functions. We don't really need to test them with unit tests, but this is just an example. But let's say I want to test this function for all the possible cases. If I want to do that, I would have to know, okay, first of all, what happens if I say multiply with loop 10 and 17, so basic positive numbers. What happens if I say 0 and 17? What happens if I say, for example, 17 and 0? Does it matter if I switch the parameters here? or if I swap the parameters here? What happens if I introduce negative values and so on? And I don't want to do that just down below with some print statements. I want to have actual tests. And for this, we're going to create a new Python file, and we're going to call it mytests.py. And here we're going to import, first of all, my functions, because we want to use the functions for testing, or we want to test the functions. And then we're also going to import unit test. And this is a core Python module. We don't need to install anything. So it is part of Python already. And with unit test, we can go ahead and create some test cases that we can just run. And they're going to say, okay, we passed the test or we failed the test. So how do we do that? We're going to say class test multiply, for example. This is a class, and this class is going to extend. It's going to inherit from unit test dot test case. So this class is a test case. And as you can see already, PyCharm tells me that I can run this. This is not necessarily the case for all editors, so maybe you're going to have to run this manually in the command line. I'm going to show you in a second how this is done. But inside of that class, we can now have some methods that are going to be tests. So the important thing for those tests is that they always need to start with the keyword test. So if I want to test this method, I'm going to say test underscore, and now, for example, with 2 positives. And it is a good practice to name your functions based on what they're doing. So you don't want to just say test 1, test 2, test 3. You want to call them test with 2 positives, or test with 1 0, or test with string expect type error or something like that. So you want to already name the function in a way that tells the developer what this test is actually testing for. So in this case, we're going to just test with 2 positives. And in order to test, we're going to use a function of the test case. And this function is going to be assert equal. So we're going to say self.assert equal. And what this function does is it takes as a parameter first a function call, and second the result. So the first thing is the function call, which in our case is going to be my functions dot multiply with loop. And here we're going to say, for example, 17 and 19 as 2 positive integers that we're going to multiply. And then we're going to expect as a result 17 times 19. So this is the actual multiplication. This is what we expect from our function, no matter how it works. If it wants to qualify as a multiplication, we need to make sure that this is the result. And of course, we can also introduce a bunch of other tests. So for example, let's say we want to know, okay, what happens if the numbers are a bit larger? So let's say I have a number like that and a number like that. Does it still work? Now, of course, we need to copy those here and remove the comma, because the result is going to be the multiplication of those 2 numbers. So does it work with large numbers? And the important thing when it comes to unit testing is you don't want to necessarily have a lot of tests. You want to have intelligent tests, because if 17 times 19 works, probably 18 times 35 is also going to work. So it's more reasonable to test the edge cases. So for example, what happens with very large numbers? You can even go with larger numbers. Or what happens if I go with very small numbers? For example, 1 times 2. I want 1 times 2, of course, to be 2. Does this work or doesn't it work? But testing with 2 positives is not necessarily the most critical thing here. Let's go ahead and try test with 1 0. And we can write a bunch of tests here. So self assert equal, or actually we can just copy that here. And here we can say 17 times 0 should equal to 0. And of course, since we have written the function as a loop, we also need to make sure that it works the other way around, because the x is for the range and the y is the thing that we sum up. So what happens if we swap? Do I still have 0 as a result? And then, of course, the critical thing is what happens with negative numbers. But before that, let's test with 2 zeros. We're just going to have one function call here. 0 times 0 should be 0. And now we can go ahead and do the same thing with negative numbers. So test with 1, negative. And the basic way of doing this is always the same. You have this function call and you expect it to return this. So in this case, we're just going to copy that. And for example, we want 17 times negative 19 or negative 19 times 17 to be the same as 17 times negative 19 and negative 19 times 17. All right, so then last but not least, we have two negatives. What happens if we have two negatives? Does this work or doesn't it work? So test with two negatives. And here we're going to say self.assert equal my functions multiply with loop. And we're just going to say, okay, negative 17 and negative 19 should be the same as 17 times 19 because the two negative symbols cancel out. So that should be the result. And we can now just go ahead and run those tests, and we're going to see if they work or if they don't work. So we're just going to click on that button here in PyCharm, run unit tests for my test. And when we run this, we're going to see, okay, here we have two problems. We have two exclamation marks here, test with one negative and test with two negative failed. All the other things went fine. So we can go to test passed here. We can see 0 worked, positives worked, and 2 zeros worked, but negatives did not work. So you can see we got different results. So this function doesn't work exactly the way that we expected it to work. So we can just go ahead and call it imperfect. So we saw that it doesn't work the way we wanted it to work. And of course, yes, we could have seen that right away. So we're not learning about how to implement multiplication here because it was obvious that this function is not going to work for negative values, but we saw that it doesn't work with the test. So what we're going to do now is we're going to have a better function. So we're going to call this multiply with loop. We're not going to call it perfect. We're going to call it better, x and y as parameters. And now we're going to say, okay, if x is larger or equal to 0 or y is larger or equal to 0, and. So if both are positive or both are negative, then we're just going to return what we had up here. But with a slight difference. So we're going to return some, but we're going to use the absolute values here, because when we have negative values, of course, we have a problem. But the reason we can do it like that is if we have two negatives, it's the same as multiplying two positives. So the absolute value is everything that we are interested in. Otherwise, let's say we have the case that x is less than 0, but y is not less than 0. Then we basically just have to say return the sum of x for placeholder in range y, and since y is not less than 0, we're going to get a valid result. And otherwise, if y is less than 0 but x is not less than 0, we can do the same thing, but with y here and with x here. There you go. So this should be a better multiplication function, but we don't know, right? So we can assume that this is right. We can also say, okay, I am pretty sure it's right, but we would have to go through all the test cases to make sure that we don't forget anything. So what we're going to do here is we're going to copy all of this here, and we're going to make a second test class here. We're going to call it class test multiply better. It's going to be a child of unit test.test case. And we're going to have the same functions here, but we're going to replace multiply with loop by multiply with loop better. So we're going to just say multiply with loop is going to be replaced by multiply with loop better. There you go. What's the problem here? Cannot find reference in my functions. Why can't you find that? Do we have a problem here? Cannot find multiply with loop. Why is that? Oh, because I changed the name to imperfect and to better. So here, of course, we would have to do the same thing with imperfect. So let's just repeat that command and change this to imperfect and test multiply. Imperfect. There you go. So I think this should work even though it's underlining everything. No. Why doesn't it work? Because it has no attribute multiply with loop better. Why doesn't it have that? It should have that. So let me fix the mistake and I'm going to go back to you in a second. Alright guys, I found a mistake. It's just a typo because I wrote multiply instead of multiply. So we're just going to copy all of this, or not copy, we're going to change all of this. We're going to say from multiply to multiply, and then it works. There you go. So now we're going to run all the test cases for the better version of the multiplication with loops. And you can see all the tests are passed. By the way, I hope I'm not blocking everything here. If I am blocking it, I'm blocking it for quite some time already, so it doesn't really matter. But there you go. So you can see all the tests are passed. So at least that what we thought about. So for example, we didn't check for invalid types, so we didn't check for type errors and so on. But for all the things that we have checked, for example, 2 negatives, 1 negative, 2 zeros, and so on, this function works fine. So let's go ahead and try another example. Let's say, for example, we have something like a function that is called length of integer. And we want to give this function an integer n. And what we want to know is how long is this integer. And we can use a logarithmic calculation for that. You can Google the explanation. I'm not going to explain it now. But it's basically just int math.floor of math.log base 10 of n plus 1. And this gives you the amount of digits. So we can go ahead and try to see that this works. So if I go print length of integer without a 0, like that, or 1, 2, 3, 4, 5, or something, and now I run this, you will be able to see that it actually produces the right results. So let's go ahead and test this, because I'm sure it won't work for all the edge cases that we can think of. So let's go ahead and write some tests for this one. So first of all, let's go down here and say class test integer length, or whatever you want to call it. It's going to be a unit test.test case. By the way, just one thing I want to mention before I forget it. If you want to do this via the command line, you cannot just run this. You have to go to the directory. For example, in this case, desktop programming Python neural 9. There you go. And of course, I have to remove this. And if you want to run the tests, you cannot just go ahead and say Python and then my tests, because then we're going to see nothing. We have to run this with Python -m and then unit test, my test, py. So you can see here failed and ran 10 tests in 0.5 seconds. We had 2 failures and so on. So we can do this in the command line as well. Just wanted to show you that. And now let's go and test this length function. So we're going to say class test length, or what did we call it? Test integer length is going to be a unit test case. And the function is going to be def. And we're going to start with a very basic test with positive integers, or with a positive integer. So def test with positive integer, and we're going to see what happens. So let's say self.assert equal, and we want to say my function length of integer, and we're going to pass 1, 2, 3, 4, 5, 6, for example, and we want to know that this is actually going to be 6 as a result here. And we're going to do the same thing for maybe 1. We want to know that 1 is 1, and we want to know that, I don't know, 10 is also 2. Not also 2, but 10 is 2. Because it's right on the edge, right? Because 9 is 1 and 10 is the first 2. So we want to make sure that that works. And then we're going to also test with negative integers. So we want to know that it also works with negative integers. So test with negative integer. And here we, of course, need to define what we actually want. We want to know, okay, if I have negative 1, 2, 3, are those 3 digits or 3 positions, or are those 4 positions? Because, of course, the string negative 1, 2, 3 has a length of 4, but the actual digits are 3. So you need to define what we actually want from the function. In my case, I want the negative symbol to be counted as an additional position. So I want the length of negative 1, 2, 3 to be 4 and not 3. So let's say self-assert equal my functions dot length of integer, negative 1, 2, 3 should be 4, and negative 1 should be 2, and negative 1, 2, 3, 4, 5, 6 should be 7. There you go. And now we also want to test this with a 0. So what happens with a 0? Def test with 0, self assert equal my functions dot length of integer 0 has to be 1 because 0 is 1 digit. And last but not least, the only thing that we need to take care of is what happens if I don't enter an integer, but I enter a float or a I don't know, a boolean or a string. What do we expect this function to do? Do we expect it to return anything, or do we expect it to raise a type error? Now, in my case, I want to expect it to raise a type error, so we're going to use a new function. First of all, we're going to create a function called test with other or with invalid type. And we're going to say self.assert raises. Assert raises. And here we pass first of all, the exception that we expect. So in this case, type error. I expect a type error. When do I expect a type error? When the function myFunctions dot length of integer is called. We're not calling the function, we're just referring to it. And the parameter is, for example, a string of a number. This should be a type error. Or just a string hello, or a boolean true, for example, or even if it's a floating point number, so something like that, for example, or also, of course, if it is a list. So let's see if our function does all of this. If we run that, we can see, okay, one test is passed, the test with the positive integers, which is the most basic one. All the other tests failed. So we need to take care of that. Let's go ahead and make this function better. We're going to start right away with the statement if type of n is not int, raise type error invalid type. So we have this case handled, and otherwise we're going to use this 1 here to just increase by 2 instead of just by 1 if we have a negative symbol. So we're going to say add equals 1 if n is larger or equal to 0, so the basic one that we already have here, and else it's going to be 2. And we're going to replace this with add. Now, the only thing that we need to also make sure is that if we have a 0, this does not crash. So because a 0 is actually undefined, log10 of 0 is undefined. So int math floor logarithm 10. First of all, we want to have the absolute value because negative values are also undefined here. And then we also want to make sure that this is only the result that we get if n is not equal to 0. Otherwise, we get 1. So we handle the 0 case explicitly here. So now I would assume as a programmer that all the problems are handled, but I don't know. So instead of just trying again with all the individual statements, I'm just going to click this one button here and I'm going to see if everything is handled. As you can see, all the tests are passed. And this is what is the good thing about testing. In this case, it is very trivial. You would not need unit tests for those functions here. It is not useful to write unit tests for such a basic collection of 3 functions here. But if you have a project where you have different classes and different functions that work together, so you have one function making use of another function, and you have complicated functions, and you change one thing somewhere in the code, you don't know if everything is still working the way it worked before. So all you need to do in order to make sure that it still does work in the way it worked before is you just have to click one button, you have to run all the unit tests, and everything's fine. So you write them once and you reuse them all the time, because these statements are not going to change, right? You still want the length of this integer to be that. Of course, if you redefine it, you can change it, but the test cases are just the test cases. They don't care about the implementation. They care about input and output. They care about the result and the validity of the result. So you just write them once and you rerun them all the time, which is a very important thing to do, especially in large projects. Alright, so that's it for today's video. Hope you enjoyed and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you very much for watching. See you in the next video, and bye.